Chapter 5. The good thing about this, as I go through this document, later on you can download and read, or you already download and just go and read. Okay, we'll talk about the inspection of aeroplane structure. Do you see the slide now?
Yes, sir.
Okay. Yes. Okay, what we're going to do here, we want to determine damage, causes of the damage, what kind of damage, because that information is very important for you when you want to write to OEM to explain to them about the damage and to ask for the required repair. We have first stage here. When you are the technical services or you're working for the airline, when you see damage, you need to repair, and some of the repair not as per the SRM, structure repair manual, and then you need to have OEM to come up with the repair. However, if your airline having the design approval to do repair, you have approval by CM, Part 21 Subpart J organization, DOA, then you are able to do minor repair, but you still need to go back to OEM for major repair. For the Part 21 Subpart J organization, DOA, you allowed to do minor repair, you allowed to approve minor repair, and then the 145 allowed to embody the repair for minor. But for the large repair, you still need to go back to the authority. Okay. For the inspection of aeroplane structure, as explained to you many times, aircraft structure is we call it as thin wall structure because the thickness of the structure can be as thin as 0.063 of an inch, which is very thin. And that's why we do have many parts of the structure, like we do have stringer, we do have doublers, we do have stringers, we do have frames, bulkhead, that one to stabilize the structure, because most of the structure are very thin. Because the thin, the structure can damage easily in operation, and that's why we need to do inspection. And also when there are structure damage, you also need to do inspection to determine the extent of the damage. So the aircraft can be damaged during operation in flight, during operation on the ground, damage due to environment, and damage due to the material itself is prone to damage. I mean, the material itself is the type which is easily get damaged, especially on fatigue, fail due to fatigue. So let's look at the in-flight damage in operation in flight. What we may have, what may cause the damage, and it can be damaged due to turbulence. The aircraft goes through weather which there is a lot of gas. Gas is the air vertical, moving vertically, and the speed of air moving up and down cause the aircraft to tumble. That we call it turbulence. And then the behavior of the wind blowing up and down, those are gas. And you can see here in the VN diagram, we already anticipated the aircraft flying with the gas speed of 30 foot per second and 15 foot per second. So we already put it in the design. We make a curve here. We have the line here. This is a gas line. And we design the structure should be within this the range here. That's why you can see here, the gas here is within the range here. If the gas like going like 50 or 60, it will be outside. Then obviously the structure will not be able to stand that high speed gas. Okay, turbulence. And some of the turbulence has caused the aircraft to crash. Nowadays, maybe we don't really see much because nowadays we do have good radar, we have weather radar, and structure also quite tolerant to that kind of gas loading. But those days there are several crashes because of the gas turbulence. However, if your aircraft encounter turbulence, it still can cause severe damage, especially on the interior part of the aircraft. You can see the galley cut, meal cut, the galley door itself open up, throwing out around, and some also you can see the overhead luggage bin also punctured. So that those are interior structure, interior damage. After gas, we may have evasive maneuver. Maybe the aircraft having a situation they are going into each other too close, so the pilot has to evade another aircraft, so that will experience of evasive maneuver. Evasive maneuver, the problem is you may already flying outside the VN diagram here in the red zone that you see that if you do that, then you already incurred damage to the structure. So evasive maneuver. Excessive vibration, also another problem. Aircraft vibration induced due to component installed, primarily because of engine failure, propeller failure. They become unbalanced. The unbalanced rotating parts will cause vibration, severe vibration. Severe vibration will cause failure on other part of the structure. Okay, propeller, yeah, some aircraft may lose the propeller tips and that also cause vibration. Flutter is another issue. Flutter is because of aerodynamic instability. The structure, the flutter affected by the unproperly distributed mass of the structure, and it can easily occur in at the control surfaces. That's why the control surfaces, after you do painting, after do repair, you have to do balancing to ensure the control surfaces are balanced, so you will not get into this flutter. So most of this flutter will caused by the imbalance of uh, control surfaces, the aileron, the flaps, elevators. Heavy landing is not the issue. When you encounter weather, you fly near the ground and you may experience wind shear. Wind shear will slam the aircraft to the ground, will cause heavy landing. Or you may also have landing short the runway. For is a pilot operational error. You short the runway, then you try to save your runway distance. You may land short, landing fast, then also that will cause that also we call it as heavy landing. That also can cause damage to the structure. Then bird strike is quite common. That's why some most airport they have this facility equipment installed to prevent birds to come in. That is not so serious, but the big bird and those are fly at high altitude, that will cause severe damage. And there are some aircraft also lost engine. They have to land in the water somewhere because of the birds striking the aircraft. And for this situation, most of the bird will strike the aircraft. You can see most of the time bird strike will cause radome to be damaged, leading edges punctured. I have experienced myself during landing one of the US Air Force aircraft was when I was working for Aero. The bird hit the flaps at the down position. They hit the flight flew under the wing, hit the flaps, and then the bird punctured the skin of the flaps, went inside, and smacked into between the flap ribs. And then we have been asked to repair. So I went there, inspect the aircraft, and we have to remove all the bird mess first before you're able to get more detail. Before we get to to inspect the extent of the damage. So it's very messy work when you have bird strike, because the remain of the birds are still there. At the same time, you have to do the inspection. At the same time, you have to design the repair. It's very messy. Lightning strike is another issue when you fly. You fly over the air and then you may have lightning. Lightning strike the aircraft is a problem because we already have lightning strike protection, which is if you don't have that, you may burn the aircraft. But still, occasionally you got bird strike, and the bird strike cause burn into the aircraft structure, and at least not burn. There is some pitted, like you have a pin, you punch through the skin, you can see all this pitting. So those, if you see the pitting, mean those are the sign of the aircraft structure has been through lightning strike. And then aircraft operation on the ground, there are many activity on the ground. You have catering truck, you have Bowser, field Bowser, you have maybe mover stairs. You don't have a gate, so they use movable stairs to embark into the aircraft, and that easily hit the aircraft fuselage or aircraft wing, aircraft flaps. So part of the aircraft fuselage. So those are also part of the ground damage due to the ground operation. Environment, as we know, corrosion. There are many types of corrosion. The corrosion, one of the defect because of the environment. You're working in the environment, especially if you work near the sea. You have this salty air environment. That salt is electrolyte, and that can accelerate the electrolysis process, which is corrosion. Material itself, I have explained earlier on the material. The material, there is a unique, every material they have a stress and cycle. For the stress, how many cycle the material will live. So similarly, in this situation, as you apply load, you have stresses, and as the structure experience those stresses, it starts to degrade. That's why there's a life to the structure, because there's a life to the material. So that is another cause of the defect, like the material itself, the deficiency in material, and normally the failure will be crack and fracture. Okay, type of damage, I make a map from each cause, like turbulence, environment, evasive maneuver, flutter, heavy landing, and we're trying to map into what could be the potential failure. Turbulence may cause structure to crack, bend, structure will deform, revert failure. You can see the reverts without heads. The revert heads pop out. Distortion on the skin panel, buckle, wrinkle. So those are the potential type of damage that you see when aircraft goes through turbulence. Evasive maneuver, you may see the same thing. Crack, excessive vibration cause crack. You can see a video on 380 when they did the Flutter flight test at Mach 0.92. They experienced severe vibration. They abandoned the test. They brought back the aircraft to the hangar, and then they inspected the aircraft, and they found a big crack around the main landing gear area. So they had to fix the crack, and they flew again. They got Mach 0.96. So that structure cracking and the vibration, because they have to fly at very high speed. The vibration, the severe vibration causes the structure to crack. So they have to repair and beef up the structure. Power propeller engine turbine failure, you can see punctured because all the blade debris will go through, if not lucky, go through the fuselage. And that's why there are sitting condition in the fuselage. You're not allowed to sit in line with the propeller, because if you lost the propeller tips, the tip can fly like bullet into the cabin. Propeller engine failure, okay, flutter. Flutter may cause crack, heavy landing, also cause crack, bend, deformation, revert failure, distortion, buckle, wrinkle. Bird strike is punctured. Most of the strike cases, the whole bird itself went through the structure and resided in the structure. Lightning strike is a pitted condition, burn, hit mark. Aircraft operation on the ground also can cause punctured, cracks, scratches, gouges. Environment is corrosion. There are many types of corrosion. So those are potential failure for the specific cause of damage. Any questions? Next,
No, sir.
damage assessment. This is one of your exercise, one of your assignment to do the inspection for the aircraft damage. So we have to do damage assessment. There are a few steps that we need to do for us to do formal damage assessment. This is one of the aircraft, C-130. I have been working on this aircraft. The aircraft went to the hangar, damaged the nose, cut off the wing, and you can see how extended the damage. You can see all those punctures. Even you can see even though there's a wrinkle buckling around this area, you can see almost all the defect there in this aircraft. What you need to do when you have an aircraft suspected to be damaged, especially when the damage is major, you have to bring aircraft to the hangar. You have to tow the aircraft to the hangar. You have to jack the aircraft, make it level, put all the support, we call it trestle, to make sure the aircraft at the condition where it relaxed, level. And from there, you're able to determine the exact extent of the defect because the aircraft is not stressed. So that is the why we need to go through this to do that, because we need to remove the aircraft to be under stress. After that, you do damage mapping. It's very simple exercise. You just go to IPC, make copies of the IPC. You walk through aircraft. When you see any part of the aircraft damage, you just highlight damage and what are the damage. So that we call is damage mapping. Another thing you have to do, for example, if you have a major defect, you have to do alignment and symmetry check on aircraft structure, because first, the regulation does not allow you to have formal deformation on the structure. You can see the fuselage wing bent up to 5 meter, 3 meter, but however, when aircraft landed, they are on the ground, you don't see any of those. So we are not allowed to have permanent deformation on aircraft. That's why we have to do alignment symmetry check. So alignment and symmetry check will determine the distortion level of the aircraft, whether they are acceptable or not. There are specific chapter in the manual about alignment and symmetry check. Then that specific requirement also stated the dedicated point on the aircraft structure as alignment point. And if you are away, there's a limit also given. If you are away from the point, mean the aircraft has been distorted permanently, and then you have to put in the report, and you have to look at where has been distortion. And most of the time, what we did, we remove at the area of distortion, we remove all the rivets, so the aircraft will go back to its own position after you remove all the defective buckle or wrinkle parts. So after that, removal, and then we continue repair. We repair after we remove the distortion or deformations.